Howdy, so for science we're looking at separating mixtures. So this is the science understanding that we're looking at. We're looking at how the differences in properties and substances can be used to separate them, and then we're going to look at identifying how components of a mixture can be separated by several methods. So filtration, distillation, evaporation, and a couple more. So I'm going to start with this question. Why is it handy to be able to separate out mixtures? So what is a mixture? In chemistry, we say a mixture contains two or more substances that aren't chemically bonded. And what that means is there's not necessarily a fixed ratio between the components. So in a compound, for example, there's a fixed ratio. So in water, there's always, two hydrogens and one oxygen. But in a mixture, you don't necessarily have any fixed ratio between the components. And the mixtures can change depending on what you're doing to them. So some examples of mixtures are air. So air is 80% nitrogen, around about 20% oxygen, and then there's a number of other gases in there. And the amount of those gases changes depending on what you're doing. Orange juice, so there's obviously a lot of water, but then there's some orange in there. So where does that come from? Tap water, so the water straight out the tap. It's not pure water, it's not distilled water. It contains salts and things like fluoride, excuse me, and paper. So paper isn't just pure wood that it comes from. It's been treated with chemicals and it has certain chemicals in it to make it certain colors. So in chemistry, it's sometimes nice to know what is inside something. So what makes up and what composes something. And the way we do that is by separating them out. Sometimes when we're separating out, we're trying to answer specific questions. So a good question is how much lead is in your drinking water. Lead is a heavy metal. It's neurotoxic. It's not good for you. And currently in the US, in a city called Flint in Michigan, they've had troubles with the amount of lead in their drinking water due to cascoding when it comes to treating the pipes that carry the water. So large amounts of lead aren't great, so you need to test the water to see how much lead is in there, and you do that by separating out, by analysing the water to see how much lead is in there. How do we make booze more boozy? So down here I've got a still. This isn't important necessarily for you guys because you should be under 18 and not drinking, but extracting alcohol from the mixture that produces alcohol is handy industrially. So ethanol is used in petrol, for example. So it can be added to petrol to reduce the cost of the petrol and also make the petrol a little bit more environmentally friendly. How do we get metals out of the ground? So metals are usually attached to minerals. We need to extract the metal from that mineral. And so again, we're separating out a mixture that contains things like silicates and other metals that might be contaminants, and we're separating them out from each other to get the metal that we want. So now we're going to look at some specific methods for separating out mixtures. Filtration is a very simple one, and separate out substances based on the size of their particles. So you probably would have used filter paper in a laboratory before. This filter paper is paper, it's got lots of holes in it. If a substance is smaller than the holes, it passes through. If a substance is bigger than the holes, it stays in the filter paper. And that's a way that you can separate out solids from liquids, as long as they're not soluble. The solids, that is. Filtration is used in water treatment, so they use these sand and gravel filters. The water that you're treating, you pump in, you let it settle through the sand and the gravel. So again, there's spaces between the sand and the gravel that are a particular size. If the particles are smaller than that, they pass through. And then that water that passes through can be treated again in a different way after that. So that's called a sand filter. Evaporation is a way of removing a solvent from a solute. So the solvent is the substance that dissolves the solute, and both together they're called a solution. So the way you do that is you take your solution and you heat it up. The vapor of the solvent comes off, and behind you're left with the solute. So that sits there. Where this is used, it's used in laboratories a lot to extract solutes from solvents, but in general, this is how you get salt. It's one way of getting salt at least. So you take seawater, you put the seawater into ponds, you let the water evaporate off of the seawater, and you're left with the salt behind. Chromatography is another way of separating out usually the components of a fluid mixture. It's based on the idea that some substances stick to other substances more, and the variation in that stickiness can be used to separate out substances. So here's an example. It's called thin layer chromatography or paper chromatography, and we use it to separate out dyes. So we can do this with food colorings and textures and things like that. You put a dot of your dye down the bottom. You rule a line normally so that you can measure how far the substances move. You pop that in paper, and because of the capillary action of the paper, the water travels up through the paper. And as the water travels up through, it takes the dye with it. Now, the dye is made up of substances that have different, what we call polarities. Polarity is a measure of stickiness, essentially. So if something is more sticky to the paper, it has a similar polarity to the paper, then it will stick to the paper. So this red dye here is more sticky than the blue dye is. So the red dye holds onto the paper much more strongly than the blue dye does, so the blue dye rises higher. That's basically the idea behind chromatography. This is a very simple type of chromatography. This is more complicated. This is called gas chromatography. And it's usually hooked up with another way of analyzing substances called mass spectrometry, which is a bit more complicated. But the idea is essentially the same. So you have a gas, so rather than using water, we use a gas, usually nitrogen. That flows through. We have a column, which is what is separating out based on stickiness. You inject your sample in, and more sticky substances, so depending on what the column is, it could be a polar or a non-polar column, but that's another discussion. The substance sticks to the inside. So if it's very sticky, it will take a lot longer to get through and come to the detector. If it's not very sticky, then it passes straight through. And what you get as your feed out is essentially how long it takes for the substance to pass through. And again, that's another way of separating out the mixtures. And then those mixtures can, the separated mixtures can then go, like I said, to mass spectrometry to be determined what they are. Froth flotation is used in the mining industry. It's a way of separating out silicates from the minerals that are in with the silicates. It's used a lot in sort of zinc and lead production. So the way it works is you have your zinc and lead ores, you crush them up to give them a big surface area, you put them into this big tank, and you add some substances in there. So you have something that makes a lot of bubbles, and you blow air into it. When you blow air, the bubbles, the substance that you want, so the sulfide ore, that sticks to the bubbles and it floats to the top, and then you scrape off the top. The substances that you don't want, the silicates, they kind of settle down the bottom, and then you can scrape them and take them out of the tank later on. So you scrape the bubbles off the top that contain larger amounts of the sulfide ore, and then you get rid of the gangue, which is the waste silicates from the bottom. By doing this, you increase the concentration of the ore that you want, and it makes it more economical to produce the metal from that. This was pioneered in Australia, froth flotation. The last one I'm going to talk about is fractional distillation. In fractional distillation, you have a mixture, usually of liquids, sometimes of gases, and you heat them up, and different substances boil at different temperatures. We've talked about boiling point before. So based on the boiling points, you can separate out substances from each other. In chemistry, we use it to separate organic compounds from mixtures. So you have a mixture down here, you heat it up. As you heat it up, you get to particular temperatures that might match the boiling point of one of the substances in there. That boils off, and you can collect that through a condenser, which cools it back down again. So you can collect that, and that's called the distillate. You might have 4 or 5 different substances in here, each with a different boiling point. So when you reach the boiling point of that substance, you get that substance coming out. Then you can heat it up a bit more, you can get the next substance, and so on and so on. So it's a very handy way of separating out substances from each other. Where it's used industrially in big scale, it's used to separate out the components of oil, and all those components are used for different things. So crude oil has a lot of different hydrocarbons at different lengths, and we use those different length hydrocarbons for different purposes. So the hydrocarbon comes in, it gets heated up, so it's really hot down the bottom, cooler at the top, and your substances separate out from each other. So down the bottom you have things like diesel, which is fairly long carbon chain, so lots of carbons. As you get higher, you get petrol. So here's petrol in here, so kind of this region. And a lot smaller than that, you get natural gas, which comes out the top. So by heating up the crude oil, you can separate it out into its fractions. That's why it's called fractional distillation. And you can get the substances that are different from each other and use them for different purposes. So by having different boiling points, you separate out the substances from each other. So why is this handy? Well, let's say you have food that's contaminated with something, or you have an allergic reaction to a particular food and you don't know why. You could analyze that food in lots of different ways. So you could mash up the food with water, anything soluble in the food, well, most of the soluble stuff in the food, depending on how long you mash it and mix it with water, will go into the water, and then you'll be left with a solid. So you could filter the food mash and you'd separate out the soluble substances from the insoluble substances, and then you could analyze the soluble substances and analyze the insoluble substances. You could distill the soluble components and separate them out based on their boiling points. So that's another thing you could do once you've done that filtration. If there are dyes present, you could use chromatography and the dyes that you get from this process here, and you could separate out the substances and you could figure out what the substances are. So if you're having an allergic reaction to a particular dye, that's one way that you could figure it out. This is just a very simple small example of things that you could do with separating mixtures. So today on Flipping Science, we looked at some ways of separating mixtures based on the properties of the substances in there. That's it for Flipping Science today. See ya.